Okay, in this lesson we're going to dive into three-dimensional geometry. And three-dimensional geometry just means that it takes up, the figure is in three-dimensional space, but it's a figure in three-dimensional space, so it has length, width, and height is what is going to make sense to most of us. But a prism is a specific three-dimensional figure whose solids is a solid whose sides or lateral faces are rectangles. Okay, the prisms are named according to the shape of their base. So you kind of get used to the base here. We're going to draw an example of a triangular, a square, a rectangle, and then we're going to give our best shot to the hexagonal one. And so to get started with this, the reason I'm having you do this is I think it helps you to become more familiar with the features of a prism. It's not so much that I want you to become an architect or an artist here, but we're going to start out drawing the triangular one. And I want to encourage you just to start by drawing a triangle that looks kind of like that. And then we're going to draw the lateral edges that come down, and then we're going to draw the lower face here. So you could kind of imagine, I'm going to do this in dashed line, the back edges that we don't see. Okay, to draw a square one, and again, I don't care how well this all comes out, I just want you to be familiar with the features. As I'm drawing kind of a parallelogram or a sideways diamond, and then I'm drawing my faces that come down, and then I'm going to try to draw my lower edges there. Okay, and a rectangular one, I want you to start out with a really skinny looking parallelogram like this. And we're going to draw our upright edges that come down. And then our hexagonal one, I think if we kind of do a double-headed arrow like this going either direction, that might be the best way to go about that. Then draw our upright edges. Hopefully this just kind of makes you aware that each of these prisms have a top and a bottom. We can't see the bottom here. Top and the bottom, can't see it here. Top, bottom, can't see it there, but we assume that it's sitting on one of its bases. So I have it sitting on its bases, and prisms are really flexible and versatile that way. I've got a little box here, and I've got the wide edge that it's sitting on its bases. I could turn it this way and have this edge and its opposite parallel plane be the bases. I could turn it this way and have this edge here and this edge here be the bases. So a prism is very, very versatile in terms of which pair of sides you identify as the base. But once you identify one, it allows you to get started in what we're going to be working on here. Okay, so we're going to be working with laterals. First of all, we're going to work toward finding surface area and volume, and that's where identifying your pairs of sides comes in handy. The lateral surface area is the sum of the area of the faces. Okay, and then the total surface area includes the lateral surface area and the area of the bases. You're like, what in the world? Okay, I think probably what you're going to, if you relate it to a room, in a room, the walls are the lateral faces, and the ceiling and floor are the bases. I think that makes sense for most of us. Okay, so as we get working through here, you're going to be finding the surface area of all of these figures, as well as the volume, the space inside. And so there's a couple different approaches that you can take to it. I just like cutting it apart because I think that makes the most sense for everybody rather than memorizing formulas. But the thing is you need to organize your work. So I'm going to give you a very distinct strategy as we work through all of these. Okay, so that's our basic information for surface area. Volume is finding that space in between. And so we use this formula where you're finding the area of the base, and then you multiply by the height. And usually this is given in this kind of a formula. Volume is equal to base times height. And we've had base and height before, but notice here in this formula, base and height are capitalized. So the capital letters usually indicates the three-dimensional base. The base, in this case, is a triangle. Up here, the base is a square. On this one, the base is a rectangle, and here the base is a hexagon. So that's where I'm saying you have to kind of decide what your base is going to be. Once you find the base of each of those areas, then you multiply it by the three-dimensional height. And that's why this height is different than the two-dimensional, and that's why we are labeling it with a capital H. Okay? Hopefully this will all fall together as we get going. So what we're going to do here is we're going to find the lateral surface area, the total surface area, and the volume. And before we can really get started with finding total surface area, we need to identify our base area. So it's actually four things that we're going to be doing. So looking at this figure here, I'm going to identify, just say that the top and the bottom are going to be my bases. And so my base, the two-dimensional figures for my base area are a 9 by 7 rectangle. So I'm going to start out finding my base area. So that's the first thing I'm going to do. So I've identified them as being the top and the bottom. So I'm just going to, again, I'm organizing and labeling my work here as I go along. So I have two of these. I have the top and the bottom, so I'm going to start out with 2 times, and the edges of my base area are 9 and 7. So 9 times 7 would give me the area of one of these, and because I have 2 of them, the top and the bottom, I need to double that. So that would come out to give me 126. So that is my base area. Total base area includes both areas, both the top and the bottom, and this would be units squared. Okay, so the next thing I need to do is find my lateral surface area. And we've got the front and the back, and then we have the right and the left. So I'm going to start out with the right and the left. And the dimensions, there's 2 of them. There's the right and the left, so 2 times, and then if I'm looking at this edge here is 10, this edge here is 9, and that would be 9 here as well. So this right side is a 9 by 10 rectangle. And that would give me a total of 180 units squared. Okay, and then I'm going to do my front and my back. And again, I have 2 of them. I have the front and the back. This is 10 here, and this is 7 here. So this would be a dimension of 7 by 10. And that would give me a total of 140. Now, I could add just the, the lateral surface area together, and so I'd just be adding these 2 together, which give me 320 units squared. So that's my second item that I'm doing. My third item is my total surface area. And that is a matter of adding. It's equal to the base area plus the lateral surface area. So you're going to see as going forward, I'm going to start abbreviating here a little bit. So when I do that, I end up with my base area I said was 126. My lateral surface area I said was 320. So when I add that all together, I end up with a total of 446 units squared, and for my TSA. So it might be helpful to start identifying each of these. Okay, and then the fourth thing that I need to do is my volume. Okay, volume, it's really very, very easy with the prism. But the formula says base area, and I'm just going to write a little area down here to remind you that it's the base area of the base times the height of the three-dimensional figure, the height of the prism. So my base area, I said, was my 9 by 7. So that part would be 9 by 7. And then my height is my three-dimensional height, which is times 10, which gives me an overall volume of 360 units cubed. Okay, so this was our volume. So those are the 4 components that we're going to be working on when we deal with any kind of 3-dimensional figure. Basically, the prisms and prisms and cylinders. We will deal with all 4 of these items. Okay. Moving forward, the next picture, the next page, you've got these 3 figures that we're going to be working with. And again, I've written on the top here, and I would encourage you to do the same just to kind of remind you what you need to be working on, and really you need to be working on them in that order because they kind of flow into each other. So you're going to start out finding the base surface area, and remember you have a top and a bottom, so you'll find the area of whatever your top and the bottom. You're going to have 2 bases. It may not always be the top and the bottom. And then you will find your lateral surface area. Your total surface area is the sum of both of those, and then your volume using that volume formula we talked about. Now I'm going to encourage that you draw lines here and you follow your work and go in order. I'm going to switch papers here because what I don't like about this with the camera is I would be sliding my paper back and forth. And I want you to be able to see the picture for every computation that we do. So I've reorganized my work and I've done it on a little sheet of paper ahead of time. I'm just going to discuss it, and then hopefully you can freeze your computer or your screen and then copy things down once I've discussed it. But again, I've written everything off kind of going horizontal here. I don't like that because I'm floating all over the place. I would prefer that you do your work going down on that, like I showed you on that previous sheet. So looking at this first one, I want you to recognize that this is a right triangular prism. Our base is a triangle. And that changes our work a little bit. Okay, but again, it's sitting on one of its bases, so the top and bottom idea works for our bases. So we're going to be starting out finding the area we're going to start with the base. We have to recognize that that base is a triangle. So we're going to be using the formula for the area of a triangle. And that formula is 0.5 or 1/2 base times height. So when I go in and I plug in that information, 1/2 times base times height, I come up with an area of 30 centimeters squared for just one of those. But there's 2. There's the top and the bottom. So my total base area